I'm controlling this LED with nothing but a knob, some math, and something called a voltage divider. Come check it out. What is a voltage divider? Well, we're going to use height as a metaphor to understand how voltage dividers work in circuits. In a circuit, voltage is defined as the difference in electric potential energy per unit charge between 2 points. So in your circuit, you're going to have a total incoming voltage and you're going to have a ground. The difference between these is how much voltage is going through your circuit.
Check this out. This is our first example. We're going to look at a mountain where the top represents voltage in at 20 with resistors of 1 kilo ohm, 2 kilo ohm, 3 kilo ohm, 4 kilo ohm, and 5 kilo ohm as you go down the mountain all the way till ground. Now, we need to understand for our math to work how the current in our circuit is going to stay the same. We have these resistors in series, and so as this happens, we find that our current stays the same, and we can calculate it by taking our voltage in over our resistance total. This gives us about 1.3 repeating milliamps. Now, to make this work, we're going to associate voltage drops with walking down our mountain. The top of the mountain correlates with the incoming voltage, where each resistor is a step walking down the mountain, correlating to the amount of voltage that is dropping across that resistor. So to find the voltage dropped by each resistor, we're going to take the voltage and equate it to our current and the resistance value of our resistor. This is Ohm's law. And we find that for resistor 1, the voltage is 1.3 repeating. That's how much volts resistor 1 is dropping. So now that we've stepped past resistor 1, we still have 18.6 repeating volts to account for across the other resistors. Now, as we walk through resistor 2, 3, 4, and 5, notice how each resistor drops the amount of voltage relating to how much resistance it has. Resistor 2 drops about 2.6 repeating, being only 2 kilo ohms. Resistor 3 is 3 kilo ohms, drops about 4 volts. Resistor 4, being 4 kilo ohms, drops 5.3 repeating, and resistor 5, the largest of them all, drops the largest amount of volts, 6.6 repeating. And notice it balances out to 0. All the voltage has been accounted for across all of our resistors. This is no accident. This is a self-balancing mechanism of circuits. Nobody engineered this. This is just how circuits have come to work. And so we see no matter how big the resistors are, how many there are, and because the voltage is set and the resistor total is fixed, that determines one current for the circuit. And because our current is set and our resistors are known, for each resistor, the voltage is divided so that all the voltage is accounted for. Check out this balancing example. Say we have a voltage input of 20 volts, and we have two resistors that are a little unbalanced. We have a 1 kilo ohm resistor and a 9 kilo ohm resistor. Then let's calculate our current at 2 milliamps, and we notice that with resistor 1 being only 1 kilo ohm, it drops 2 volts, while resistor 2, being a much larger resistance, drops 18 volts accordingly. This is fitting, seeming that resistor 2 is much larger than resistor 1 in terms of how much resistance it offers. Still, we get down to 0 volts, all volts accounted for as we traverse our circuit and as we walk down our mountain. So we can use voltage division for two good uses here. First, we can find the voltage dropped across one resistor. We can do this by taking the voltage input and multiplying it by the resistor value that we want to find the drop over the resistance total in the circuit. Or we can find the voltage at a node. This is kind of like you've traversed through your circuit and you want to find the voltage at a given point in between resistors that have already been passed through. So say you've walked halfway down your mountain and passed through a couple resistors, but you still have some resistors to go before you reach the end of your circuit. There's going to be a voltage level there that you need to account for the voltage being dropped already and the voltage still to drop. So to do this, we're going to use voltage input times the resistance value total of the resistors below over the resistance total in the circuit. Now, to help us simulate a little bit, we made a circuit in LTSpice. This has two nodes, and node 1 is before a resistor of 200 ohms, and node 2 is after. And we see at node 1, we start out with 9 volts coming from our voltage source, and we drop 6 volts across our resistor. This just helps us verify our math is not crazy because the simulation speaks truth. By voltage division in a fun way, we're going to use a potentiometer. Potentiometer is a voltage divider that's used by a knob to help us adjust how much voltage is being consumed by the potentiometer and how much voltage therefore is left for our circuit. We're going to hook up our potentiometer in a series circuit with another resistor and another LED. Check out what happens in a second. Before we get there, we're going to use some code that gives us some active feedback on what's going on with these values and how we can relate them to the LED's reactivity. As we turn the knob on our potentiometer, R1 starts to decrease. R1 is how much ohms is being soaked up and therefore how much voltage is being taken by the potentiometer. As more and more ohms are being given to R2, which is unaffecting our circuit, the circuit gets more and more voltage. This voltage is being taken by our LED, which allows it to reach its forward potential and light up. I could offer you a good explanation for voltage division, how you can use it, and what it looks like in practice. Stay safe, have fun dividing, and you got this. Take care.